A very good afternoon, respected professors, dignitaries, participants, and dear students. Welcome back to the final segment of International Conference on Applied Algorithms 2026, organized by the Department of Computer Science and Engineering of Heritage Institute of Technology, Kolkata. Today, in the first half, we have heard a talk on anytime algorithms for approximate functional dependencies by Professor Gautam Das and non-linearity of Boolean functions combinatorial results with cryptographic significance by Professor Shubhamoy Moitro. We also saw the presentations of some papers from track B, AI, and machine learning. This final segment of ICAA 2026 is structured as follows. First, we will have a technical session on track B, AI and machine learning, where 5 papers will be presented. This will be followed by the valedictory session and high tea. Without any further delay, let us begin the technical session. We are highly privileged to have Dr. Onindo Haldar as the session chair. Dr. Onindo Haldar is presently working as an associate professor and the head of the Department of Computer Applications, Northeastern Hill University, NEHU, Tura campus, Meghalaya, India. He also worked as an associate professor in the Department of Computer Science and Information Technology, Cotton University, Guwahati, during July 2022 to July 2023. Prior to joining Cotton University, Dr. Haldar has worked as an assistant professor in the Department of Computer Applications, NEHU, since July 2012. He received his Master of Computer Applications degree from University of Kalyani in 2005 and PhD degree in engineering from Jadavpur University in 2012. He worked towards PhD as a full-time research scholar at the Center of Soft Computing Research, Indian Statistical Institute, Kolkata, during August 2007 to July 2012. He was a visiting scientist at the Remote Sensing Laboratory, University of Trento, Italy, during January to June 2010. He has published a number of research articles in internationally reputed journals and refereed conferences. Dr. Haldar received Young Scientist Research Travel Grant from DST Government of India in 2010. He served as reviewer in various reputed international journals and conferences. His research interest includes machine learning, deep learning, pattern recognition, swarm intelligence, soft computing, remote sensing image analysis, biomedical image and signal processing, bioinformatics, and natural language processing. We are really honored to have you here, sir. Please come up on stage. Thank you, sir. We request you to chair the session. I also request the presenters of the papers with IDs 27, 46, 52, 56, and 95 to please be ready. Over to you, sir.
Hello. Good afternoon to you all. So, in this session, we have 5 research papers to be presented, out of which 3 will be in online mode, as I have seen, and 2 will be in physical offline mode. So, may I request the first paper, that is paper ID 27, Stocks in Cluster Award Deep Learning for Multi-Stock Forecasting in Financial Market, to present the paper.
Yes. Please give me a minute. Can you please...
Let me declare that each presenter will have 15 minutes time, out of which 12 minutes will be dedicated for the presentation and 3 minutes for the discussion. Please maintain the time frame. Okay, over to you.
Yes. Can, sir, can you please enable screen sharing? Explain.
The presentation. Please share your screen and your screen.
Yes. Good evening, everyone. My name is Shubham Sahu. Uh, to, today I'm pres presenting our research paper, Stocks in Sync, Cluster-Aware Deep Learning for Multi-Stock Forecasting in Financial Market. Uh, Forecasting stock price movements very difficult due to market volatility, non-linearity, and interstock dependencies between different stocks. Traditional models often fail because they treat every stock in isolation, ignoring the fact that correlated stocks often move in same directions. For example, in Nifty 50 index, we often see that stocks which are in same in industries or often share same sectoral dynamics. Uh, so this work proposes a cluster-aware deep learning framework that uses a co-movement based clustering to identify sectoral structure. And by combining clustering with multi-output LSTM and a ticket embedded architecture, the model captures shared sectoral dynamics and improves next day stock direction prediction. Our motivation was that in case of single stock prediction, we have to build uh, n number of different models for each stock. So the compute power will be much more used as compared to multi-stock detection, where we have uh, strong sector-driven movement. So multi-stock will comparatively use less compute when we compare with single stock price prediction. And when discussing different papers and what are the problems they have addressed and the research gap they have left out, we, we are seeing that most of them don't have joint multi-stock detection, and they are limited to single stock modeling. And in case of papers which are using GraphML is highly complex, and due to being very complex, its scalability is very limited. And so in methodology, now I can talk about the data preparation part, but the other points we can discuss it in the next slides also. So for data preparation, we are using historical Nifty 50 stock data And after that, they are clean, normalized, and transformed into binary next day movement labels and technical indicators like RSI, MACD, MACD are also included as well. And these are the equations for the two up two LSTM approaches which we have uh, proposed. So uh, before going to the LSTM approaches, we can first discuss about the end-to-end process for stock clustering via co-moment analysis. Uh, so first we load the historical data and we have all the features along with it. So I have noticed that uh, the things which I have noticed that stocks which are in similar sectors like banking, so SBI and HFDC, their stock price movements is kind of similar as compared to stocks which are in different industries. So what we have done is we are trying to uh, make clusters of stocks which are in similar in industries. So that was one of our main approaches. And after that, we have applied exponential weighting. Uh, exponential weighting does the thing that mm when we are uh, comparing prices for like and bank, which is uh, the main idea of applying exponential weighting is that we are trying to uh, is 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 smoothen out stocks which are kind of have very high noise. So we are applying exponential weighting for that. After that, we are generating a similarity matrix. Similarity matrix is used for uh, to map out which stocks are much more similar to each other. Then after that, there are two branches. For first branch, first branch can be like building a cosine distance matrix by just uh, computing the mm, like one minus similarity matrix. By that, we can compute our uh, cosine distance matrix. After that, we are applying MDS, which stands for multi-dimensional scaling on distance matrix. We are not using PCA, principal component analysis, because PCA removes the temporal structure of the features. And after that, we are converting it to embeddings, and we are storing the embeddings in a map, and the key are the ticker IDs, which means the stock names. And here we are performing hierarchical clustering instead of k-means or GNN or any other clustering method, because in mm, k-means we have to select a certain number of clusters we have take it, but here it is not like that, and then we can visualize them as dendrogram, and then we are outputting the clusters for modeling. So here we can see that if you notice, like Gale and ONGCs are in same sector only, which is the petroleum sector. So they are highly correlated as compared to uh, stocks like mm, I, ITC or Bha- uh, other stocks. So that was one of our main approaches. And now we are coming to our flagship model, which is the cluster-aware LSTM architecture. In this, we are collecting the features for all for 46 stocks, but the issue was that when we are when we are using the features for all for 46 stocks, the model performed very poorly. So what we are trying to do is select cl clusters of 7 to 8 stocks together, and then we were uh, concatenating the features horizontally, which means like stock A,
Yes, we
feature A,
have 3 minutes left.
feature A, feature B, and then we were applying a scaling and sequence generation. Then after that, we are applying a time distributed encoding layer. Uh, for Then we were processing them in parallel, like LSTM for LSTM 30 is for uh, short-term prediction, and LSTM 60 is for next 60 days. And then we are concatenating their outputs. Then we are uh, running them through a common dense layer, and then we are producing multi-head outputs for different stocks. And then we are predicting the binary movement prediction per stock. This is the flagship model, and mm, this is the ticket embedded LSTM architecture. Here we have once again collected the features for all 46 stocks, and then we have inputted input combined stock data with ticker column. It means that for each row there's a unique ticker column ID, and then we are concatenating them vertically. Like we are increasing the rows of the data set. Then then we are applying standard pre-processing, standardization, and sequence formation. And then we are ordering the columns in a stratified way, maintaining temporal order, which means that uh, for stock A, we are storing them the rows in a way that day one, day two, day three, day four. Then there are two branches which we have made, like we have passed the temporal features to LSTM, and then we have used the embedding map which we had generated earlier on, and then we have combined them with the temporal features, and then
Kindly conclude. You are only 1 minute left.
the results which we have shown you using the cluster where dual LSTM is is the best we have produced when we are comparing with a VAR baseline, which is statistical in nature, and a genetic algorithm rule-based baseline. Here we have achieved mean F1 score of 0.77 and mean accuracy of 0.72. And for ticket embedded LSTM, we have achieved a mean F1 score of 0.72 and mean accuracy 0.7. Conclusion is that a cluster where multi-output LSTM framework effectively captures sectoral co-movements and stocks specific patterns for next day's stock direction prediction, and uh, experiment on Nifty 50 stocks show consistent performance gains over traditional and existing deep learning models. In the future work, we like to extend the framework by switching from intraday to intraday modeling and explore advanced architecture like GraphML and longest forecasting horizons, like a larger time window for improved robustness and scalability. Yeah. And these are the references.
Okay, thank you. Now, if audience have any questions, may raise. No questions from the audience side. I have one question. So I have seen that in your deep learning block, you have used two parallel LSTM blocks, right?
Yes. Yes, sir.
Same deep sequential learning architecture is used in parallel.
Yes.
For that LSTM.
Pardon, sir, I can't hear a question.
Two same deep sequential learning architecture is used in parallel. It could have
Yes.
been two different deep sequential learning, like one LSTM, another GRU, something like that. Have you tried with other combinations?
Yes, sir, we have tried LSTM, GRU, and CNN and GRU methods, but they were not sorry, they were not giving us good output.
Okay, take. So have you noted down those results? Those results, have you compared those results?
Yeah. Yes, sir. Yes, sir. Uh,
Results are not there. Yeah. You may just stop your presentation now.
oh,
So we'll proceed to the next paper, that is paper ID 46. Neurosymbolic AI-driven mental health risk prediction with human readable rule extraction and interactive explainability. Authors from the paper may come up on the desk. Yeah, it is an offline presentation. So time is 15 minutes, out of which 12 minutes are dedicated for presentation and 3 minutes for discussion.
Hello. Hello everyone, my name is Shayan Pal and I am from the University of Burdwan. And it is our privilege to present our work into this prestigious conference ICAA 2026. The title of our paper is, a neurosymbolic AI-based mental health risk prediction framework with human-readable rule extraction and interactive explainability. And my co-author is Dr. Rahul Kormakar. And our paper ID is 046. So the things which we will cover in our upcoming slides are like the data preprocessing or not the data preprocessing first. We will discuss the data set, then we will discuss the features of our data set. Next, we will discuss the pre-processing phases which we followed during our development phase, and also the feature selection methods. Then we will discuss the classifiers which we used in our development in our framework, and also we will discuss a little bit about the tuning and the validation. And then we will discuss the neurosymbolic AI, output of the neurosymbolic AI. And also we will discuss a little bit about the dashboard which we developed at the ending layer of our framework. And also we will discuss the results, limitations, and future work. Before starting my slides, I would like to discuss one thing, that what is actually the problem that we are trying to solve. See, there are different type of AI models or agents that they are into market, which are very much efficient in predicting mental health illness. They can accurately predict whether a patient is affected with mental health illness or not. But there is a common issue with all these AI agents or AI frameworks. That is the issue with the interpretability. Though they perform very well, though they predict the disease very accurately or efficiently, but they cannot explain us why they are saying so. They're just giving us the output in such a way like you have a high chance of mental health illness, you have a low chance of mental health illness, but they cannot explain us why they are saying so, why they are saying that you have a high chance of mental health illness or you have a low chance of mental health illness. So I have right now I told you the term interpretability. So the models which are already available in market, they are very much efficient. So why we need another framework? Why we upgrade the framework? So why we need the interpretability? See, the frameworks are obviously they are very much the already available framework. They are very much efficient, but they cannot explain us the reason behind those answers. That is, so sometimes it badly affect the reliability of that model. If one doctor or the clinician use those AI agents, they can take the output from the framework. But whenever these agents or these AI models cannot explain the reason behind these models or these outputs, they cannot completely rely on this framework. So from this, to reduce this, we developed our framework, or we chose our goal initially, that is to develop a neurosymbolic AI-based mental health risk prediction framework with human readable rule extraction, and also our framework has an UI. So, okay. So these are the contributions of our framework. Like the first contribution is that we develop a neurosymbolic integration. The second contribution is the rule extraction, some human understandable rules which are mainly generated on behalf of the outputs. Next, our third contribution is the interactive explainability, and our fourth contribution is the strong empirical results. These things which we are going to discuss these things into the upcoming slides. So I am sure that many of you have a common question in your mind, that what is actually neurosymbolic AI, right? See, if we separate the term neurosymbolic AI, then we will get two terms. One is neural network and another is the symbolic AI, or in more details, we can say it as symbolic reasoning. Clear? We all know that the neural networks are very much efficient in data pre-processing. They are very much efficient in analyzing the patterns. They can learn from the patterns. They can learn from the data. These are very much efficient. These are the advantages of neural network. But there is a drawback with the normal neural network models. What is the drawback? They cannot explain us. There is an issue with the interpretability or the explainability. On the other hand, if we see the symbolic AI or symbolic reasoning, this thing, they can generate some rules. They can generate the reasons behind the outputs. They just analyze the output and generate the rules or the reasons behind those outputs. Also, individual symbolic reasoning or symbolic AI has a drawback. That is, they cannot learn from the patterns. They cannot understand the data like the neural networks can do this kind of things, but the symbolic AI cannot execute this kind of things. So both the neural network and the symbolic AI, both these things have some advantages along with some disadvantages. So if we merge these two things, then we will definitely remove the disadvantage from both these things. Because how we can do this? The neural network, they have the issues with the interpretability. So whenever we added the symbolic reasoning to neural network, so it will not only generate the output, it also gives us the explanations behind those outputs. And also there is one drawback of symbolic reasoning, that they cannot learn from the data, or they cannot understand the data set, or they cannot understand the pattern. Whenever we added the neural network with the symbolic AI, the neural part will understand the data, analyze the data, generate the outputs on behalf of data, and the symbolic AI part generate the rules from those data. So this is all about our dataset. Due to a large size of our dataset, we cannot attach the screenshot of the dataset. Initially, our dataset has 10,000 number of rows, which we are saying that raw records, along with 14 columns, or we can say it as attributes, right? And among these 14 columns, we have our target column, that is termed as risk, where we have three type of values, like low, medium, and high. into our dataset, there are different type of characteristic feature of our dataset, on behalf of which we separated the features of our dataset. Like there are some demographic features like age, gender, employment status. There are also some behavioral features like work environment, physical activity, sleep hours. Also there are some psychological indicators like depression score, anxiety score, etc. And along with these features, our dataset also has some historical records of each patient, like prior condition, treatment seeking. Also here we discuss a little bit about the pre-processing, though we are going to discuss this thing into upcoming slides. But here we just say that we use outlier technique for detecting and removing the outliers from our data set. Next, we use the data balancing for balancing our data, and also we use feature selection for selecting the most relevant features, which we are going to discuss into our upcoming slides. So this is the overall framework of our data set, where we just fetch the dataset from our local machine and we take it into our Jupyter notebook. We use the Jupyter notebook for developing our framework. Next, we perform some data pre-processing phases. Like firstly, we check whether our dataset has any kind of null values or not. Next, we check whether our dataset has any kind of categorical values or not. As our dataset has different type of categorical values, so that is why we have to encode the categorical values into numerical ones, or more specifically we can say it as we have to convert all the values into integer ones. Why we need that? Because we all know that the machine learning algorithms or the neural models cannot understand the categorical values directly. They only understand the integer type values, right? So we have to convert those values, or we have to convert our dataset completely into numerical ones, so that the normal machine learning models or the classifiers which we used in our study, the model can easily be fitted into this kind of things. Next, we perform outlier detection, and then we perform use the data balancing technique. In our case, we use mode. Next, we perform feature selection using chi-square method. Next, we splitted our dataset into different type of trend test splitting ratio like 70, 30, 80, 90, 90, 10. Along with them, we also use the 10-fold CV for justifying the stability of our model and hyperparameterize our model using hyperparameter tuning. And also we use another layer that is the most important layer in our framework, that is the neuro-symbolic AI layer for interpretability, for adding the feature interpretability to our model. And lastly, we added a dashboard or an UI so that a normal person can easily interact with our framework. So these are the pre-processing phases. First, we check, as I already told you, that we checked whether our dataset has any kind of null values or not, and then we encoded our dataset using we encoded the total dataset using label encoder. Next, we perform outlier detection. In our case, we use the ICAA method for detecting the outliers and removing the outliers, and then we perform data balancing because our dataset was oversampled. So we use mode for balancing our dataset, and after that, we normalize our dataset using max min standard scalar. Here, sorry. Here we can see that before using the outlier detection technique, our dataset initially has 10,000 number of rows. But after applying the IQR method, we were able to find out that our dataset have around 566 number of outliers. So we have to remove these outliers. So after applying, again we apply the IQR method to remove those outliers from our dataset. And after applying the IQR method or outlier detection method, our dataset was updated, and our updated dataset has 9,534 number of records. Next, we perform mode for data balancing, right? Initially, our dataset was oversampled. So that is why we use mode technique here. After applying this mode, we got 16,851 number of samples in our dataset. And all these samples are equally distributed into the values of the target column. That is, what was the target column? That is risk, which has three number of values, three type of values, low, medium, and high. And the samples are equally distributed into these values.
Go to your result section, please.
Okay.
Only 2 minutes left.
Okay. So this is the output section. After applying hyperparameter tuning, we again splitted our dataset and calculated all the evaluation matrices like accuracy, precision, recall, F1 score for different type of classifiers, like random forest classifier, logistic regression, dictionary classifier, MLP classifier, and XRT classifier. And among them, the random forest classifier outperformed the other models with an exceptional accuracy of 99.26%. Though some of you definitely thinks that there is a chance of overfitting, but as we use a rigorous data pre-processing phase, so there is a very less chance of data overfitting. And This is the output after applying the 10-fold CB. Again, though we calculated the evaluation matrix after applying the 10-fold CB for all the models, but this time again it is the random forest classifier which achieved the highest accuracy, that is 99.14%. And here comes the rule section, that is the interpretability section. Other models, they only stop into after generating this thing, after generating the outputs. But our model generate not only just giving us the output like you have high chance of mental health illness, you have low chance of mental health illness. Along with them, they also give us the reasons or the rules behind that, on behalf of which they are saying that you have a high chance or you have a low chance. Like these rules are saying that if depression score is less than equal to 0.47 and anxiety score is less than equal to 0.52, then the risk is low. And also there are other type of rules generated here, on behalf of which our model or our framework generate the final output. And here we just attach an example UI for our, though we are currently we are working on the deployment phase, but it was on our local host where we can see there are different type of input values. What the user has to do, the user only give the inputs to these input values. After giving the inputs to these input values, the user, whenever he or she click on the prediction button, the UI will generate the chances of mental health illness into three approaches, like high chance of mental health illness, low chance of mental health illness, etc. Also, not only just giving the answer to us, it also giving us the reason behind the answer. It says that suppose the UI generated the output as high, and not only it generated the output as high, it also gives us the explanation like if anxiety is greater than 0.55 and seek treatment equal to no, then the risk is equal to high. So the user or the normal user or normal layman, they're not only just getting the output, they're also getting the reason behind those outputs. This is a comparison which we performed during our writing our paper. Though our primary approach was not to develop a framework which has higher accuracy in comparison to the other frameworks. Rather than our approach was to develop a framework which has these features. But still our model somehow achieved the accuracy of 99.26%, which was the highest in comparison to the other models. So what are the things our framework has? Our framework has a predictive accuracy. Our framework has rule-based interpretability. Also, our framework has a practical deployment. Though we use a very rigorous pre-processing or rigorous steps for developing our framework, but our framework also has some limitation.
Yes, conclude.
So in conclusion, we are again saying that we have developed a neurosymbolic AI-based mental health risk prediction framework, which not only just generating the outputs in high, low, or medium in this term, it also gives us the reason behind those answers. It also gives us the rules on behalf of which they are giving us those outputs, or on behalf of which they are generating those outputs. And here are some future directions on which we can work, like we can use the nested CB rather than using 10-fold CB, which we used in our framework. Also, I would like to highlight one thing, though that was not written here. We can work with knowledge graphs. Why we can work with knowledge graph? Because the neurosymbolic AI, that framework, the neurosymbolic AI, they are very much efficient with working with the knowledge graph. Though they can easily handle the CSV files, but if we use the knowledge graphs with this neurosymbolic AI, so then they can definitely generate more advanced rule, more easy to understand rules to us. So these are the things which we can work in future. These are some of the references which we used during our literature survey. Thank you.
Thank you. Any question from the audience side? Since no questions from the audience, I have some questions.
Yes, sir.
So you have claimed that you developed some neurosymbolic AI-driven mental health framework for risk prediction of mental health, right? Using interactive explainability. So, and there you have shown that random forest is performing the best among all the other methods.
Yes, sir.
And random forest is a rule-based, based on desentry, right? Desentry-based classifier. So and your claim is that interactive framework is because of the fact that it is showing the rules also, right?
Yes, sir.
So if then rules it is generated.
Yes.
Any desentry-based approach you use that generates the if then else-based rule generation policy.
Yes.
How your claim is novel with regards to that?
Sir, the rules which were generated by our framework, we double-checked this framework with some of my friends who are already in medical sectors. They are doctors. We just not officially but unofficially I verify these rules to them with the help of them, and they verify these rules.
Agreed.
Yes.
What my point is that any rule-based classifier like decision tree you use,
Yes,
that will generate, that will make the decision based on this rule only.
Yes, sir.
So with regards to that, how your model is novel to claim that it is a interpretability and explainability is present?
Sir, we just use the title because if we highlight the machine learning portion of our framework, so these things only calculate the accuracy or give us the normal output.
Even if you do not use that term in the title, so without that also, any extra thing you are not doing, right? For interpretive analysis or explanatory analysis,
Yes, sir.
only decision tree or random forest you are using, which is a rule-based classifier.
Yes, sir.
Okay, so I don't agree with that actually.
Okay,
don't claim anything don't claim anything which you have not done.
Yes,
Okay,
sir.
that is the first point. And another is that nowadays explainable AI is a separate concept altogether. If you use the deep learning concept, their explainability is dealt in different manner. Like GradCam based system is there. Okay, SAP analysis is there. So you can look at those things in future. Okay. And you have discussed about the data pre-processing, right? So there you have shown that data balancing you have shown. I would like to know from you that how you have uh, uh, dealt the missing value problem. In your data, was there any missing value?
No, sir. As we collected the dataset from Kaggle and we checked whether our dataset has any kind of null values or missing values or not. And initially we found that there are no null values or missing values in our dataset. So we do not concern with that.
Maybe in this dataset it is not there available. But if missing value is available, then how do you handle it?
Initially, we will remove the null values from that from our dataset using some that function which is used by the Python, like drop na method. This kind of.
There are some concept like missing value imputation technique,
Yes,
like KNN missing value imputation. You can go through that.
Okay.
Okay. Thank you. Okay. All the way.
Thank you, everyone.
Next, we have the paper ID 52, Deep Learning Based Intrusion Detection in IoT, a cross-modal performance analysis. Is it an online or offline presentation? Offline, okay. I request the presenter to come on the dais, please. Paper ID 52. Time allotted is 15 minutes only, so 13 minutes for the presentation and 12 minutes for the presentation and 3 minutes for the discussion.
Okay. Okay, thank you. Okay. Yeah. Am I audible? Yeah. Good morning, good afternoon, everyone present over here. I am Shaptashi Bhattacharya, and today I'll be presenting my paper, Deep Learning Based Intrusion Detection in IoT, a cross-model performance analysis. I'll just. No, next slide. Next slide. This working fine. Oh, okay, fine. Yeah. Okay, so this is how I'll go for this presentation. I'll start by briefing a little bit about the motivation and the backgrounds. Then I will briefly describe the related works under this topic. Then I will move on to describing the work that we did in the paper, and then I'll conclude by the future work. The reason behind choosing this topic was that IoT technology and IoT devices are the use of these two things are increasing multifolds in the present timeline, and so is the cyber attacks on both of the IoT technology is also increasing. So this makes this topic in current modern day time frame not only very relevant but also very critical. The major challenges faced in IoT security is that most of the devices are very weak, have very weak security configurations, such as weak patching and default credentials. Coupling that with the complex attacks that attack methods that modern day cyber attackers use, the traditional security mechanisms seems insufficient to it. This is where deep learning comes to our aid. Deep learning has this ability of understanding complex underlying patterns uh, to detect anomalies in network traffics. Let's move on to the next one. Yeah. So in methodology, the methodology that we followed was that we first identified the data set among the all present available to us. We studied some of the existing implementations of deep learning methods that are already done before us. And from that, we applied various new and modern deep learning methods. The reason behind choosing RT-RD dataset was that it had a variety of attack patterns. Along with it also simulated real-time data, real-time network traffics. It also has high quality labeled data, which makes it easy for, which makes it suitable for applying deep learning methods. Our reason for choosing ACI IRT dataset was that it has fine grained labels. It also provided multi-domain traffic. Yep. Okay. When we studied the existing implementations of various people before us in our TIRT dataset, we found that transformers and hybrid deep learning models gave excellent results when it came to accuracy. But we also saw that class imbalance was a major problem in most of the implementations. Thus, class weighted loss and smart technologies we incorporated in our models for better results. In ACI IRT dataset, we found that transformers and neural models perform better. I know it's written hybrid, but yeah, it would be neurals. Sorry for the mistake. So transformer and neural models achieved better results. When it came to class, it also had a lot of problems regarding overgeneralization, which we had to cut down. These are the 5 deep learning models that we have implemented. Autoencoder was implemented for anomaly detection. Federated learning was implemented for privacy. It kept privacy along with deep learning. Neural networks were for modeling device implementations. Contrastive learning, SimCLR was implemented for giving a contrastive learning, and transformer was used for far-fetched advanced underlying net. Sorry, once. Yeah. Transformer was used for capturing long far-fetched underlying patterns. Coming on to the results, we can see for RT-IRT dataset, transformer and contrastive learning performed the best when it came to accuracy and precision. When it came to ACI dataset, federated learning outperformed all the other models. The conclusions later. This is a comparison between all the average of all the metrics across all the models for each of the data sets. Moving on to the next. Radar chart gives us a holistic comparison between not only between both the data sets. Just a preview, in radar chart, the closer the metric is to the outer line, it is better, it perform better. As we can see that in MCC and Cohen's kappa, the difference between both the models are the maximum, which highlights the difference between both of them in when it comes to agreement and when it comes to agreement of the predicted labels with the true levels. This is a heat map just to give us a better comparison view of both of them. Yeah. So for conclusion, I'll just say that this showed that the transformer and SimCLR achieved the better results when it came to RT-RT dataset, while federated learning performed better on the ACI, which highlighted the difference between both centralized and decentralized learning settings. This comparative analysis also showed the difference between the trade-offs between accuracy, computational efficiency, and deployment constraints across the evaluated deep learning paradigms. Yep. On the scope of the future work, we want to we can incorporate under explainable AI. We can also include some edge case. We can also include the power consumption study also. Yep. So, yeah. So, this time.
Thank you. Any question from audience? Okay, no questions. So I have a couple of questions for you. So I'd like to know first from you that this dataset RT IoT 2022 and ACI IoT 2023 datasets, how many classes are present there?
How many classes? Right now I can't recall it. Sorry, sir. Right now I can't recall it. Classes.
Okay. Is it a binary class problem? Or?
No,
No,
it's not a
multi-class
binary.
problem.
Yeah, multi-class problem.
Means there are different types of intrusions at all.
Yeah, different types of intrusions. But for for our understanding, I during the pre-processing, I changed it into binary
Binary
class.
one.
Yeah.
Ultimately, you have converted to the binary
Yeah, I
classification problem.
converted. But in the original data set, there were multiple classes.
Okay. Go back to your result section, please. Yeah, wait. There. These are the results. Move forward, please. This is the results for the average of all the methods,
Yeah.
or which methods results it is?
All the average.
Average of all the methods you have done,
Yeah, on
implemented.
each. Yeah, because
what does it suggest?
Because the pipeline.
What is the outcome of it?
So actually, the pipeline of both the of all the methods was same. Like for a same model, the pipeline for it was same for both the data sets.
No, but method ultimately classified is different, right?
No, sir. It's this. The pipeline is fully same for both of them. So what we tried to achieve by this was we shown that under the same pipeline, the RT-RT dataset is the industrial dataset, and ACI dataset was a more controlled environment. The dataset was captured. So we wanted to
go back to a previous slide, please. Like here from this bar chart, we can see that this is the result for the transformer, GNN, this, that. But for the next slide, those results are for which method?
We all the 5 models that we have applied.
You should mention that, okay?
Okay, sir. Sure.
And otherwise, it looks ambiguous.
Sure, sir.
Okay, and go back to the next slide, please. Acha, one more question I have, that you have only compared with the methods which you have implemented, right?
Yes, sir.
But I have not seen any comparison with the existing techniques from the literature.
Oh, okay, so yes, that is missing from.
Please consider that in future work. Okay.
Okay, sir.
Because if you do not compare with the existing techniques from the literature, then how your method is performing better, that cannot be judged properly. Okay, that's all from my side. Thank you. Next presentation is for the paper ID 56, comparative evaluation of adaptive wavelet transform and classical approaches for EEG preprocessing in stress recognition. In online mode? It will be in online mode. So I'd request the presenter to join online. time is total 15 minutes, out of which 12 minutes is dedicated for presentation and 3 minutes for the discussion.
Shivangi, you need to connect your audio. Shivangi, if you can hear us, please connect your audio.
Yes, sir.
Yes, you may start presenting.
Share your screen, please.
Sir, am I audible?
Kindly share your screen, please.
Sir, am I audible?
Yeah, you're audible and your screen is also visible. You may start now.
Okay. Good afternoon. I am Shivangi Tyagi, research scholar in Banasthali Vidyapeeth, Rajasthan. I'm presenting my paper, Comparative Evaluation of Adaptive Wavelength Transform and Classical Approaches for EEG Preprocessing in Stress Recognition. Here is the table of content. The first is my abstract. First is EEG signals are used for stress recognition due to their ability to capture subtle neural narration, but
Your
they are
slides are
often
not moving.
My slide is not visible. Now it's visible, sir.
Yeah. Can you make it in presentation mode, full screen mode?
Sir, whenever I play in full screen mode, it's not changing the slides.
Please, in this mode itself, you continue.
So EEG signals are widely used for stress recognition due to their ability to capture neural variation, but they are often contaminated by ocular, muscular, and environmental artifacts, making pre-processing essential. So in this work, I generally compare basic classical pre-processing method like bandpass, simple wavelet denoising, and adaptive wavelet transform on which I am working. In this, I am using root mean square error and signal energy to calculate. So in my research paper, the experiment results on benchmark EEG datasets show that my adaptive wavelet transform achieves the lowest average mean square energy error. It's 0.75 into 10 to power minus 7 as compared to classical method like band pass filter and wavelet transform. Additionally, AWT gains the highest signal energy, which is 96.66% over band pass filter and wavelet transform. Now the introduction. Here is in my journal paper, I have took the using the EEG electrodes on scalp. Firstly, important thing is that why we are using stress measurement, because it impacts our health and well-being. We are so it's very necessary to detect the stress nowadays. So for this, we have been using a frontal electrodes which captures the stress and emotional activities. They are basically for when we use a EEG signal, it is in raw signal form. We have to pre-process. It means pre-processing means we are removing the noise and artifacts from that raw EEG signals, which we are capturing from the frontal electrodes on the scalp of a person. So basic, they are very classical method, wavelet transform, but here we are using adaptive wavelet transform. These are the challenges which we are facing in EEG processing for stress recognition. First is common EEG artifacts. EEG recordings are contaminated by artifacts such as eye blinks, muscle activity, line noise, and electrode motions. When we are using the electrode, so what we are getting EEG signal, sometimes it is disrupted by the eye blinks of a person or muscle activities. Other than artifacts overlap with EEG bands. In EEG, mainly what we are focusing in EEG frequency, we are divided in sub bands. Sometimes these bands, due to some noise, can overlap over each other. Next is dynamic nature of EEG noise. EEG noise is non-stationary and time varying, which requires pre-processing method to adapt dynamically. And the last is impact on stress recognition reliability. Inadequate artifact removal diminishes the reliability of extracted neurophysiological features. These are the literature review in which what we have considered three types of approaches. First is classical approaches, wavelet-based approaches, and adaptive wavelet transform, which we are using. So in classical approaches, band pass and notch filtering were used, which you remove the power line noise and baseline drift. But the drawback of this, because it is it's having very limitation with non-stationary signal. Next is wavelet based approach. Benefit of this is time frequency localization is there, and it's having the better MSC, mean square error is better than a basic band pass, and energy preservation than filters. But it can't fix the wavelet basis and threshold. According to it, it's very time to time. But the adaptive wavelet transform, we use dynamically adapts wavelet basis. Basis will be constant in all the cases, and the noise and other artifacts are suppressed in adaptive wavelet transform. This is the flow diagram. Like, firstly, we will use EEG signal. We will import from our database. And after that, we will apply three types of pre-processing. One is band pass filter, second is wavelet transform, third is adaptive wavelet transform. After comparing it by using the parameter of root mean square error and energy, we have find that adaptive wavelet transform giving the better performance in both the parameters cases. So if we are talking about the classical EEG processing technique, there are three types of basic methods. First is band pass filtering. Another one is independent component analysis. And next is traditional wavelet denoising. In band pass filtering is used to remove baseline drift and power line interference noise. And in independent component analysis for separating neural signals from artifacts. And then the last, traditional wavelet denoising, we use the fixed threshold values, which is used, but for fixed values, it is often require manual tuning and does not adapt well to changing EEG noise. So in the last, which we have used method wavelet transform technique. It's having various things like discrete wavelet transform. In discrete wavelet transform, decomposes EEG signal into approximation and detail coefficients, enabling time frequency localization. Means in DW, when we will use DWT, our EEG signal will be divided in detail coefficients. Decomposition, for decomposition, we will use a 9-level decomposition DB4 wavelet capturing method, which will divide the EEG signal into different bands like delta, theta, gamma. And traditional wavelet denoising, classical fixed thresholding method, which can be hard or soft. It suppresses noise by modifying the wavelet coefficient. but can miss subtle neural signals due to their static nature. And the last is adaptive thresholding method, in which we adjust the threshold dynamically based on the signal and noise characteristics. And these are the research gaps which we have covered in my journal which I covered in conference paper. First is classical method limitations. In the classical method, we can suppress non-stationary and overlapping EEG artifacts. Second is fixed wavelet constraint, in which conventional wavelet thresholding uses fixed bases and thresholded. Next is limited AWT adoption in stress EEG. Adaptive wavelet methods remain underexplored for stress-related EEG processing. And the last is, which is common, insufficient comparative evaluation. We have the very lack of comparison using metrics like RMSE, SNR, and energy preservation. These are the mathematical formulation which we have used in our EEG denoising. Basically, earlier I have said we have used band pass filtering. So band pass filtering, we have used the convolution and we have used notch filter, which is here a notch filter at frequency F0 suppresses line noise. Then next is the wavelet transform, which provides a time frequency localization by the decomposition of the signal into approximation and detailed coefficient. In here we mainly focused on approximation and detail coefficient. We have used 9 levels. So at each level we have find out
3 minutes left.
Approximation and detail coefficient. These all are the thresholding, and on the basis of energy level and noise basis, these are the equations. And these are the results. These are the methodology which we have used. Firstly, we have taken a raw EEG signal recorded by 36 healthy adults. After that, we have arranged in like this. We have a single channel EEG waveform, which we have using sampling frequency 500 to 512 hertz. After band pass filtering, we get this signal. This is a denoised EEG signal. Here we use the DWT decomposition, which will give the 9 level of approximation coefficient, and and this is the comparison of DWT versus adaptive wavelet transform. Here is the comparison of EEG signal denoised using classical wavelet transform and adaptive wavelet transform. Here, what it's representing that higher order of wavelet coefficient from D3 to D9 are more subject to noise. To denoise this signal, we applied the wavelet transform by using the fixed threshold rule, and adaptive wavelet transform to decompose noisy EEG signal using base shrink threshold. So these are the two comparisons in which we have seen denoisy signal using fixed threshold or using base shrink threshold. Two types of
conclude. 1 minute left.
And this is the last one, comparison of denoise signal using wavelet and adaptive wavelet. And this is the final result in which we have compared the MSE, in which we have seen that adaptive wavelet transform achieved superior denoising. And this is the energy preservation, in which adaptive wavelet transform retain up to 97% of the signal energy, which is better than other traditional or classical method. So this is the conclusion of my paper, that adaptive wavelet transform giving the better energy preservation and MSE over than classical and band pass. These are the references which we have used. Thank you. Thank you, sir.
Thank you. Any questions from audience side? Okay, no question. I have some questions for you. Okay, then I have this work you have carried out is primarily for uh, denoising the EEG signals for stress recognition using wavelet transformation, right? So now, what you have done is that you have proposed some adaptive wavelet transformation framework for EEG denoising, and you have compared you have evaluated your method by using the mean square error value and energy,
Energy
calculated the
preservation.
energy of the signal.
Right.
But since your method is primarily meant for stress recognition from EEG signal, so it would be better after denoising the signal if you could show how much accuracy it achieves for stress recognition purpose by applying the denoise signal to some classifiers. That would give more insight to your claim that it is actually and properly denoising the EEG signals.
Okay, sir, and I will take care of this, or I will consider in my next work.
Ultimately, your objective is to recognize the stress from the EEG signal, and in order to do so, you are denoising the EEG signals by some adaptive wavelet transformations framework. And as long as you cannot show how much accuracy you achieve by denoising for stress recognition purpose, your claim somehow is not justified. So please consider that in future. That's
Okay, sir, I will take care. Definitely.
okay.
Okay.
Thank
Thank
you.
sir.
You may sign out and stop your presentation, please.
Okay, sir.
Sign out means you may be online, but you stop your presentation, please. Our next paper is the paper ID 95, which is ensembling handcrafted features for accurate multi-class brain hemorrhage classification. So I request the authors to join the presentation, and the presentation will be in online mode, right? I request authors to join the presentation. Already joined?
Yeah.
Okay. Please share your screen
Yeah, sure, sir.
and unmute yourself. And time slot is 15 minutes, out of which 12 minutes are for presentation and 3 minutes for discussion. Please maintain the time.
Okay, sir. Oh, can you see the screen, sir?
Your screen is visible and you are also audible.
Yeah. So, good afternoon, everyone. So, my name is Ankita CS, and I'm the co-author of this paper and assembling handcrafted features for accurate multi-class brain hemorrhage classification. So, let me start with what is brain hemorrhage and what are the types of brain hemorrhage classifications. So, brain hemorrhage means bleeding within and or around the brain, usually caused by the rupture of blood vessels. It is a type of hemorrhagic stroke. It is also a medical emergency, and there are five types of brain hemorrhages, and that the first one is intraventricular hemorrhage and subarachnoid hemorrhage, subdural hemorrhage, and epidural hemorrhage, and intracerebral hemorrhages. So here is the introduction. So we have collected a vast amount of
Please
data
continue.
sets. Yeah. We have collected a vast amount of data set, which is the high quality set of real patient CT images. And using those CT images, we have we have got a lot of data set, and we have combined all the data sets. And the second point, you can see that we have applied some advanced image enhancement methods. And we have of course we know that ECT images, we can't easily detect the where particularly the brain hemorrhage has been occurred. So for that detection, we have done a framework where we can capable of identify brain hemorrhages, and we have combined the convolutional feature extraction with some traditional classifiers. Shall I move the page, sir? Can you hear me, sir?
Visible. Please continue.
Okay. So here is the literature review. So before starting any work, so definitely we'll do some work. So we'll do some paperwork. We'll find out whether any of the people have started any work or have proposed any work. So of course we got two papers where they have done somewhat related to our work. And when we saw the accuracy, that is one paper, Singh and Kumar, who has taken the data set from BRA, TC, and ICH data set. So the model that they have used is efficient net basic deep feature plus SVM linear kernel, and they have got the accuracy, that means performance, that is 93.80, and same as in this the second author who has got 94.20. And we got the target that we have to do something better than them. We have to get performance or the accuracy which is more. So this is how we set it our pipeline. That is, this is our proposed work where we bifurcated into two sets. That is, first one is training phase and testing phase. You may ask, what is training phase and testing phase and how you did this? So in training phase and testing phase, we divided the data set 1 and 2. So we started doing we started our project with the training phase, that we collected some of the CT images, as I said before. After that, we have used it to detect that particular where the region of interest. So we have used it YOLO V11, and through that pipeline we have moved to the extraction, the feature extraction, and the dimensionality reduction, and followed by the knowledge base. And in the same as like testing phase also, we have done the same thing, but here we have we have combined both training and testing, and we have done that. Here also in testing phase, we have taken a large amount of data set, and we have detected the hemorrhage using YOLO V11, and the feature extraction and the dimensionality reduction, both in both the cases it is same. Then we have done the classification, and we have labeled where exactly the brain hemorrhage has been occurred in the images which we have collected. So here is the data set description, as I was mentioning. So, and the types of hemorrhages. Here you can see I have taken 5 plus 1. You may ask, what is 5 plus 1? As I said, there are 5 hemorrhages, but I have taken normal. The question arises, why normal? Because without a normal image, how can I bifurcate or differentiate this is the hemorrhagic one and this is the normal one? So I have collected some of the normal brain images so that I can compare with the defected one. So in the data set 1, you can see that the amount of data set which I have collected, and data set 2, a new data set, and the combined data set is also I have mentioned. So here you can see I have represented with the images. First image shows the healthy brain and the SDH. The SDH means subdural hemorrhage, where the bleeding between outer layer and the brain surface. And there are two types of hemorrhages in subdural hemorrhage. One is acute and chronic. And you may ask, what is acute and chronic? Acute means which is because of sudden accidents or sudden head damages, whereas chronic means it basically happens, it is most relevant in the elder age people. So then EDH, which is epidural hemorrhage, bleeding between skull and the outer layer. So, and IPH means intraparenchymal hemorrhage or intraventricular hemorrhage. So where the bleeding between the brain's ventricular systems, this is a intracerebral hemorrhage. Intra IPH means where the bleeding is inside the brain tissue, and it is the very most common type of brain hemorrhage. And IVH, I said it before, that is intraventricular hemorrhage, and bleeding into brain's ventricular systems. And SAH means subarachnoid hemorrhage, where the bleeding in the space between brain and the tissue that occurs. So these are the categories of brain hemorrhage. As I was mentioning about YOLO here. So YOLO is used to segment the image. So you may ask, what is segmentation? Why you are using YOLO? The reason is, the radiologist or wherever I have collected the data set, they have given me the raw data set. They haven't cleaned it. They haven't they haven't mentioned which is the region of interest. My duty is to detect which is the region of interest, the region which I want to focus. So on that topic, I have taken this YOLO V11, enhance the CT image and to look into the region of interest. And it has detected and segmented the region of interest. So here is the result of analysis. The first thing the in this performance analysis, first thing, as I said in the training phase, I have used a data set 1 with number of features. So the number of features are the, you can see hog 156 1568, for example 1568 features, number of features I have got for the feature hog, and the accuracy minimum maximum average I have got, but this is so low, so I want to try it more. So I have done all the feature extraction methods, and so the total the types of images I have is 5, like 5 plus 1. So where I take consider 5 features, like 5 images. So I want 100% result. Of course, I'm targeting for the 100% result.
You have only 3 minutes left.
Okay. So while doing that, I have combined all LBP and LDA features, and I have kept the number of features. I have trained the model to give me the number of features is 5. And the same as for the data set 2 also, I have combined HOG, LBP and LDA, and have got the 95.23 is the highest average. When I combine both the data sets, the combination of all the feature extractors, that is HOG, LBP and LDA for the 5 features, the highest percentage accuracy I got is 96.13. And this is the comparative analysis. You may ask why you have only showing me LBP and HOG. I have tried all the methods. In all the methods, you can see that I have got 96.2 and 96.13 in SVM RBF. That is the highest accuracy I have got. So I was mentioning about LBP and HOG. And here is the comparative analysis. I have also did the accuracy check for KNN, RF, DT and everything. So while comparing with everything, I have got for this LBP plus HOG. So this is the proposed work outcome. As I was saying, see here in the first image, you can see I have inputted the image, then the region of interest is detected, and it has been segmented, and the brain hemorrhage is identified, and it is normal. And in the second image, you can see it is intraventricular image, bleeding into the brain's ventricular systems, same as all the other types of brain hemorrhages I have done: subarachnoid, subdural and intraparenchymal. And after doing, in the beginning, while I was showing the literature review, I have said that we have did some research over the other papers, existing works, that is which we have got the accuracy 93.80 and 94.20. And hello. Okay.
Please conclude quickly.
Okay. And our proposed work where we got the accuracy or the performance that is 96.13 percentage. With the model we have used is HOG plus LBP plus LDA with SVM RBF. And here is the conclusion. This work process proposes two-staged and assembled work framework for accurate classification of 6 intracranial hemorrhage types. And uh, we have used YOLO, VLOVE, basic train region localization, and we have achieved 96.13 accuracy. Yeah, and the framework demonstrates strong generalization and real-time suitability with future scope for multi-model data integration and volumetric hemorrhage analysis. And these two papers are reference. We have taken it as reference. Thank you.
Any question from audience side? Since there is no questions, I have a couple of questions for you, Ankita.
Okay.
So the data you have shown two data sets you have used, but you have not mentioned any data source. Where from you got these data sets?
We have collected from the hospital. These are all hospital data sets. It is not online data sets.
Not publicly available, right?
No, no, no. Because it was confidential and we can't
I got
mention
it.
it.
Another question is that since you have the two data sets with you ready, okay,
Yeah.
so you could have performed the cross-domain study. Cross-domain study is the means when you are using the dataset 1, you test with dataset 2. That will give you the idea about the generalizability of your model, okay,
Yeah.
and robustness of. Similarly, when you are training with the dataset 2, try to test with dataset 1. That will substantiate your generalization ability of the model. And that is called the cross-domain study. Please look into it in the future.
Yeah, sure, sir. Thank you so much.
No more questions. Thank you. That's the end of the all presentations.
Thank you, sir.
Over to you.
Thank you so much, sir. Thanks to all the presenters. And once again, thank you, Dr. Haldar. May I now respectfully invite Professor Debranjan Sarkar to the dais to felicitate Dr. Haldar with a memento as a token of our gratitude. Thank you, sir. We will now move forward to the valedictory session. So we will take a minute or two to set up the stage for that. I request the audience to quickly take their seats. We will now begin the valedictory session of ICAA 2026. I request the following respected dignitaries to please come up on stage and take a seat. I request Professor Bimal Kumar Roy, Professor, Cryptology Research Group, ASU, ISI Kolkata, Mr. Probir Roy, Executive Director, Heritage Institute of Technology, Shri Pradeep Agarwal, CEO, Kalyan Bharti Trust. Sir, please come up. Professor Bashok Chaudhury, Principal, Heritage Institute of Technology. and Professor Proshenjit Gupta, Program Chair of ICAA 2026, Track A, Discrete Algorithms and Applications. Please, sir. We are really privileged to have your presence. Now we will move forward to the valedictory talk that Professor Bimal Kumar Roy will give. Professor Roy did his schooling from Ramakrishna Mission Vidyalaya, Narendrapur. He did B.Stat and M.Stat from Indian Statistical Institute, followed by PhD from University of Waterloo, Canada. He has been a faculty member of ISI Kolkata for nearly 40 years. He was the director of ISI during 2010 to 2015. He also served as the chairman of National Statistical Commission during 2019 to 2022. His research interests include cryptology and security, statistics, and data science. He has received many awards, including Padma Shri in 2015, IBM Faculty Award in 2007, and NASI Reliance Platinum Jubilee Award in 2007. We are truly honored to have you, sir. We request Professor Bimal Kumar Roy to please come up and address the audience. Thank you, sir.
Thank you. Thank you for the introduction. Thank you to mainly Bashav and Shubhashish for getting me here. I've been here many, many times. Nothing new to me. I've met Pradeepji also. And I was just telling the memento he had given me in the last visit is still a prize occasion thing with me, and I do have it all the time. Now, on this occasion, I was thinking what to talk, and Shubhashish told I may be allowed to speak for 20 minutes. So let me see what can I talk about 20 minutes. I'll talk about two issues. One issue is I also hear everywhere machine learning, machine learning, machine learning everywhere. And then I also hear, since I work in the cryptology, cybersecurity, this domain, that machine learning algorithms are attacking our cybersecurity domain. They can actually, it seems, crack and hack. This is one. Now in this, so I'll speak something about this. Machine learning and security, they are the opponent or they are friends. They can move together. And I just had a student finishing PhD just 2 months back who worked in this domain. So what we did there, I was trying to look into this machine learning attacks on the crypto systems. I carefully looked into the papers that come up. I told my student also to read those things which are coming up. And then what I found out is this. They've got one issue very correctly. The procedure, I'm not very sure about it, but they got the issue correctly. What is the issue? So when you have a crypto system or a cyber security domain, we store things, we communicate things, only all in binary form, 0 and 1. And what Shannon has told, if that sequence, the information of that sequence or that content is 0, nobody can do anything. So what we try to do? We try to encrypt in some sense, in a way that after the encryption, what we get the 0-1 sequence, they look absolutely random. Now this absolute randomness is a very abstract criteria. And if I want to speak in a very plain language, what is absolute randomness? This means, or I can actually reduce it to what I'm telling right now. What is absolute randomness? If I had an unbiased coin, if I had an unbiased coin. I don't know any unbiased coin. I don't know anybody who can say that I can manufacture an unbiased coin. I'm yet to see an unbiased coin. But if I had an unbiased coin, and if I could go on tossing it independently, as many times as I like, for head I put 1, for tail I put 0, then I'll be generating a sequence of 1 and zeros. That's what is absolute randomness. That sequence will be absolute random. Now there are all, and I can, well, people have shown that this will satisfy Shannon's criteria, blah, blah, blah. But the question remains that the notion of perfect unbiased coin and independent tosses, these are very abstract. I don't know how to do it. Nobody knows it as of today. I heard that if there's a quantum machine, they can actually generate one. But the conventional machine don't generate one. So what do? We have got all these outstanding computer scientists all over the world. They have designed algorithms, many. And what they try to show, that the algorithm will produce a zeros and ones. And they will take their hypothetical abstract sequence zeros and ones. And they can derive the properties that sequence should have. All kinds of properties like the simplest is zeros and ones should be equal in number. Okay, the autocorrelation should be 0. So we can define many properties which that absolutely random sequence should have. And people who are designing these algorithms, they will try to show that their generated sequence have these properties achieved. But that doesn't guarantee anything. So we have a notion of, in probability, that some distance between my generated sequence and the absolute random sequence. And
what you can give a puzzle where you can use the bias point if you are unbiased?
No, I can do it, but that assumes independence. I don't know what is independence. Yeah, I know. I teach in my class, but that assumes independence. I don't know how to do independent tosses. So we have a notion called a distance between a truly random sequence and what maybe Paramartha designed an outstanding algorithm to generate these sequences. Some distance between these two. The distance should be ideally 0 if his sequence is also random. But we often find, I have seen all the algorithms, that's not 0. That's what we call bias. Now, what the machine learning algorithms have done, since there's a bias, they could somehow understand the nature of bias. If they study enough pair of plain and cipher, if they have studied and they can get a nature of the bias. So this is certainly an attack. So what the ML algorithms are trying to do, how do they identify the bias? And then it becomes our job. So I get a feedback from the ML algorithms, and I'll try to make my system stronger. So I try to redesign my algorithm in such a way that ML learning will be failing. This is also we do. So this is helping me more than spoiling my system to strengthen my system. So I take it positively. But the claim that they can actually attack the system is not that strong or not that real, but they can find some bias, but which helps me again developing my system better. But the other side, this is very important, very, very, very interesting. And this is none less than Adi Shamir, who came for IndoCrypt in year 2020. He came once in 2000, then again gave the invited talk in 2020 or 21. So what he did, he does with his machine. These talks are very different, not like slides. He got a laptop. He was taking the Tesla's algorithms to identify the traffic symbols. So he picked up the stop symbol. So if a Tesla driverless car moves, so this comes an input, it's an image to this algorithm, Tesla's algorithm. But the input is basically a bunch of pixels, an array of pixels. and then the output becomes, you press the brake. What he does, he takes the same algorithm, same stop sign, and he would judiciously choose a few pixels and change the value there. Grayscale image 0 to 56, maybe some 251 becomes 239, some value 7 makes it 12, and does it. And then visually it will look like stop sign. If I'm driving my own car, I'll see stop. I'll stop. But the input changes for the Tesla algorithm and gives the input to the Tesla algorithm, and the output is press the accelerator. Goes boom. He says, and he showed not only this, he showed many traffic symbol identification. Shamir could actually break the entire machine learning algorithm. You just make the little bit change in the input and the output becomes entirely different. Second, why is that so? We're not trying to attack the ML algorithm, but this because most of the ML algorithms I've seen, they're not robust. Very sensitive. So that sensitivity helps me to spoil the system. Yeah, that's what Shamir claimed. Now we are trying to show. So now what the ML community is telling, that sensitivity may not be the best criteria. People believe that because of this kind of crypto attacks, they're thinking that it has to be more of robust than sensitive. So in a sense, we are helping each other. This was my first problem. The second problem is a national issue. When I was chairman of the National Statistical Commission, this issue came up and it's yet to be resolved. The solutions we got is not to the satisfaction of the government. So I tried to say that except for some intelligence and defense information, why should government hide any information? They can actually publish in the public domain, even financial information. Okay, so but then the issue comes privacy. So you think of, I have taken a loan. So if I put the information on the web and I'm a defaulter, I don't like people to know about it. But I say this is important because if I don't need to know the name of the persons, if I can actually find out that this particular SBI branch in Gorihat, they have given loan of so much of worth, say 1,000 crore, 99% to only 3 people. I don't know the name of these 3. And all the 3 are bad debts. If people can know this one, then this will be a deterrent for the SBI branch to grant such loans. So I think people have the right to know how the branches are behaving with our own money. So the question comes, if I make a regulation that the banks have to publish this one, but then the question comes privacy of the customer. So how do I publish this information in the public domain so that no information is lost except the identity? So what we have seen again, that the easiest solution may think that we just drop the name and address. Okay, but that's not really the case. Intelligent people can find out from the data that is the person, this is Shubhash's loan. Some SBI branch, some address, name not there, but people, there are smart people who can find out. Even I can give in a hackathon to students, they will find out, identify the people. So the problem comes, how can we publish every data of the government except intelligence and defense in the public domain? So no identity is, so I have to give a proof. There's a notion called differential privacy, or privacy, that I have to give a proof, mathematical proof, that by publishing this way, number one, no information is lost and nobody can derive the actual identity of the person. Now this has become a challenging, I would say, probability plus computation issue. And I was seeking, as the chairman of the commission, many solutions. We got some solutions, but it's not really up to our expectation. So that's a really open one. If some student, somebody can come out, we actually did some hackathon also on this issue. If we can, in fact, for the image one, Heritage had a prize, first or second? First, Heritage was the first prize, but that's only certain kind of anonymization. Yeah, Heritage was the first prize. So on defense, so this is, but for the problem still remains for any kind of data that the government has. How do we publish in a public domain? See, I think they were stopped. Sanjay Das has been transferred. You know this. So thus fairness of academics is not liked by the government. This is also an unfortunate part. so Heritage could have been involved in big way with the West Bengal government, but the government is not interested. They are simply happy not publishing anything. The kind of thing I am trying to propagate, but the central government is still open. They are not still getting something like a binary data. You don't know how to publish it and yet give a proof. See, I need proofs, both the ends, that I'm not losing any information. Same time, no entry is being disclosed. So this, I think, central government is still interested. Yes, I'll get you connected. Okay, so this is a one burning issue of our government, and it's a very important issue. And I told you when I was the chairman, I had a one chat with Prime Minister Modi ji, and he agreed to this. That yes, इसमें कोई गलती नहीं है, ये हो सकता है. If privacy can be ensured, then certain these publications should be allowed, or must be allowed. So this is one problem. I thought I will talk about it. And the other thing is that this machine learning and the cyber security, these domains are, I think, complement to each other. They shouldn't fight with each other. They attack only to improve their system. Okay, thank you.
Thank you so much, sir, for sharing your insights on machine learning and cybersecurity, and also for giving open challenges and problems to the audience. So this platform is actually for innovation and for thinking solutions to new problems. I hope one of you in the audience will take it. Now I request Professor Shubhashish Mojumdar to please come up and felicitate Professor Roy with a memento as a token of our gratitude. Thank you, sir. We are truly honored to have with us Mr. Probir Roy, Executive Director, Heritage Institute of Technology. Mr. Probir Roy did BSc in Chemical Engineering from London University and MSc in Chemistry from Jadavpur University. He also did MBA from Leeds University, during which he was the recipient of Commonwealth Scholarship. He is the director of Kalyan Bharti Trust and an independent director of a number of private sector companies. Mr. Probir Roy was the former sheriff of Kolkata and former president of Calcutta Club Limited. He was also the former managing director of Bengal Chemicals and Pharmaceuticals Limited. Mr. Roy was recognized as the best managing director of public sector undertaking and was awarded Scope Meritorious Award of Excellence by Honorable Prime Minister Shri Atal Bihari Vajpayee on 1st April 2000 for turning around a sick public sector undertaking. Mr. Roy was on the board of various public and private sector companies and was an independent observer in GRSE for 6 years. We are truly honored to have you, sir. Thank you for your gracious presence. I now request you to please come up and address the audience.
Good afternoon. Respected dignitaries on the dais and off the dais, all of them are dignitaries. I am the most incompetent person in the whole audience to talk about on this subject. So I can only say that I am sure you had a fantastic interaction for last 3 days with so many really brilliant faculties all around you and the brilliant participants here. I wish the outcome of this seminar will bring some hope and some ideas which will be of future use for our country, and wish all of you all the best. Thank you very much.
Thank you, sir. It amazes us when you say that you are the most incompetent person present over here, but it does not surprise us because the quality of great people is their humility. So thank you once again. I now request the CEO of Kalyan Bharti Trust, Shri Pradeep Agarwal ji, to please come up and felicitate Mr. Prabir Roy with a memento as a token of our gratitude. I now request Shri Pradeep Agarwal to please come up and share a few words with the audience.
Good evening to all of you. I think you heard us during inaugural session, and I must congratulate Subhasis Majumdar to convene this international conference consecutively. So we had a last year very successful, and this year I think a lot of speaker got added, and a lot of distinguished lectures were also present. So and this the valedictory session, what sir told, it is very relevant. What is happening in hackathon and other places, what is central government is doing. But I believe that the Smart India Hackathon and the initiative like ISRO has taken Antrich Bharti Antrich Hackathon, where our team got runner up and honored by the Honorable President of India. So I think things are happening when we are talking about that we are fourth economy in the global world. So we are aspiring for the much ahead. So we have to be all together, like the entire country has the largest number of youth of 40 crores, roughly 40 crores. So I think everybody has to be ignited. Everybody has to think differently with creativity. So if we go for these things, things will change. And during this deliberation, there were, I think, 9 brilliant presentation. What I got the feedback. So I think that will lead to a different chapter of our innovation. So thank you very much. Thank you all the participants who joined in last 3 days. And yesterday cultural program was brilliant, performed by our heritage students. I congratulate the entire heritage team to organize in such a fashion. Thank you very much. All the faculty, yeah, faculty also all the part of the group. So thank you very much.
Thank you, sir, for your encouraging words. Next, I request our principal, Professor Bashuk Chaudhary, to please address the audience.
Well, good afternoon to all of you. On the dais, we have a very, very distinguished statistician of the country and of the world, I will say, because Professor Bimal Roy is a very distinguished professor of statistics, guru of Shubhashish Majumdar. So he is here and he is loved by everyone, whoever comes in contact with Professor Bimal Roy. We have Prosenjit Dev, right? Professor Prosenjit Dev, who is the chair of this particular conference. We have our CEO Pradeep ji, and we have Mr. Praveer Roy, who is the executive director of the Heritage Group. We have the most respected teachers of the Department of Computer Science and allied disciplines in the audience and the students. We have two very distinguished professors from one from Belgium, the other from Slovenia, and they have been here right from the beginning of the conference to the end of the conference, and they will be the best judges to comment on the quality of the conference, if I can say. They will go back home and they will reflect whether we have been able to do good in this particular conference. So, it is a very, very important kind of, apprehension and premonition in our mind. When they send their email back to us, that okay, it was reasonable, you get something like 60%, 70%, then we'll be happy. Because we always give this conference ourselves very good marks. Now, right from the introduction of the conference, inaugural session, to the different sessions, particularly the first lecture was by the professor from Belgium, and part of it I heard. When it started becoming that binary thing, it started becoming ternary or tetranary or things like that. I felt that it was time to leave the hall, so I left quietly, requesting Professor Shubhashish Majumdar to inform, to make me understand when he gets some time what this gentleman was really speaking. So he is there, he must be laughing about or rather thinking about the ignorance of that person. I was really pleased with the professor of Slovenia because any Bengali, whoever he gets some time, he will talk about politics. So I could get some time, and with him I spoke about the world politics, and even the great man from the great men of the different countries, they all came up in our discussion, and I was very happy with his personality. Thank you very much for coming. These two gentlemen, they have been here, and I am indeed grateful on behalf of the institution, on behalf of all of you, on my personal behalf. I convey my regards and my best wishes to them. And I'm sure that, in future, if we request them, they will again think of coming to this country. Thank you very much. Thanks to all my respected colleagues, right from Madam Onurina, Madam Nilanjana, Madam Reshma, and there is one more madam who did that, a student who did that beautiful, um, drama yesterday about the Bhoot and things like that, Bhoot and Petni. Uh, she was there. The another TA, her voice was excellent. Deep Shikha madam. I do not know each one of them, but every one of them. But the point is, they were beautiful. They were great, simply great. All the students were great. And what to say about Shubhashish Majumdar, because he will make sure that I stay here up to the end of the program, and it was indeed a gift to me. I went home and I was telling my wife and my children that it was a great program that happened. I'm sure that you liked the food that was served over here. I'm sure that the general logistic support that has been given by the management, that has been good. Pradeep ji always ensures that, this kind of programs happen in the campus. And we want all of you to, in future, organize this kind of program in a much better manner, because I'm saying it is not that, if it is good, better is not an enemy of good, right? And best is not the enemy of better. So the point is, we should always strive to do good in terms of our academic and organizational success. That is what we should all try. There is no selfishness about it. There is only commitment about it. There is only determination about it. So that is what I just would like to tell you. Thank you very much, all the participants, all the professors who have delivered lectures, all the students who have acted as volunteers, all my respected colleagues of this institute, all other colleagues from other institutes, they have done tremendously well, and it has been a very happy memory. What happens from tomorrow? Tomorrow again you go back to classroom, but this conference will keep resonating in your mind to some extent. Oh, it happened that way. It happened that way. How do I forget Diganta Sengupta? How do I forget Diganta Sengupta? Because he did a tremendous job, very silently. And even today he has gone to my office to call me. I mean, he was not to. If he informs me, that is enough. But the point is, you have been so wonderful. I am really proud of you, because I could get the privilege of working with you at the fag end of my career. I have been privileged, because you have been my colleagues. Thank you very much. Thanks to all of you. Thanks to all my students. Do very well. Make us proud. Make the institute proud. And let such conferences be organized again and again by different departments, and let you be the examples, so that the next time it becomes better. This way, if this is good, next time it will be better. If next time is better, next time will be the best. So that's how we should proceed, and I'm sure you will do that. Thank you very much. The last point that I will say, the two overseas guests will be with us for another day or so, and then they will leave. I wish both of them a very happy journey back home, and I am sure that we will have our collaboration intact in future too. Thank you very much.
Thank you so much, sir. Your words always encourage us. And as you said, that there's really no limit to excellence. So we are good now. We will be better and even better till we outdo ourselves. And we are really glad that you enjoyed our program. Thank you for that. Now I will request Professor Proshenjit Gupta. He's the program chair of Track A, ICAA 2026, Discrete Algorithms. Please come up, sir, and say a few words.
So it's nice to see yet another successful version of ICAA completed. While sitting there, I was actually thinking about the first time when Shubhashish came to me, that was 2013. And we brainstormed about this conference and with then principal Professor Pranay Chaudhary. So initially we were thinking that, so I'll just mention a few things, how we have progressed. So we were thinking that it would be very difficult to get a Springer LNCS publication. That was our initial thought. It would be very difficult. So we applied, there was no reply from Prince Springer for 1 month. And then our friend in Greece, who is also been with the conference every time, Christos Zaroliagis, Professor Christos Zaroliagis from University of Patras, who is again our program co-chair this time as well. So he introduced us to Professor Dorothy Wagner from the Karlsruhe University in Germany, who wrote a mail in German. I still remember, may have a copy of the mail somewhere. Wrote a mail in German forwarding our request to Springer again, second application. And then it finally came through. So from there, it took some trouble to get the affiliation. This year, Springer accepted our request in 4 hours flat. At 8 a.m. in the morning, I sent the mail. By 12 noon, we had the approval for getting the LNCS publication. So I think this conference brand name and heritage also is now a known entity with Springer also. So I'm happy to be successfully helped in this conference. And this time, actually, we were able to publish the proceedings, online version of the proceedings one day. This is again a photo finish. Evening before the conference, it was online. Okay, so I think it was great teamwork from the entire set of faculty and again student volunteers and all. I couldn't participate in the last time I attended all the sessions. This time because of health reasons I could not attend every session. But whatever I could see, we have actually been improving. Thank you very much.
Thank you so much, sir. You have been one of those pillars whose relentless efforts have made this conference happen. And we wish you a speedy recovery. We all know that you are suffering from some health issues for the last few days. And we are really glad that you could make it here. We wish you a speedy recovery, sir. Moving forward to the distribution of certificates. As we move to the end of ICAA 2026, let us not forget to appreciate everyone who made this conference possible. We thank everyone for playing their role responsibly for the smooth execution of this conference. We will now proceed to the distribution of certificates. Certificates will be given to the respected session chairs, reviewers, presenting authors, and to all the student volunteers. To present the certificate to the session chairs, I request Mr. Probir Roy to please come up. I request John Iacono, University of Brussels, Belgium, to please come up on stage. Professor Uroš Sibes, University of Ljubljana, Slovenia. Professor Uroš Sibes is also an author of a paper, so he also gets the certificate of presentation. Professor Mondar Mitro, CVPR, ISI Kolkata. Is Professor Mondar Mitro in the audience? Okay. Professor Aniruddha Dasgupta, CTO, Zamify. Professor Anindo Haldar, Department of Computer Applications, Northeastern Hill University. Thank you, sir. I now request Professor Bimal Kumar Ray to please come up. Okay. Professor Shujoy Shaha. Is Professor Shujoy Shah in the audience?
Next, Professor Prosenjit Gupta,
Mr. Krishanu Datta. Mr. Shubhajit Datta. Thank you so much, sir. The session chairs wonderfully led the thread of the session, promoting inquiry and knowledge, and also ensured that the session ended on time. A big round of applause for all the session chairs of ICAA 2026. At the heart of the conference is research and innovation. We thank all authors for submitting their work in our conference. The presenting authors who are in the audience now will get their certificate, while the online certificates will be given to the other authors. I now request Shri Pradeep Agarwal to please come up and present the certificate to the presenting authors. Shayan Pal, University of Burdwan. Shoptoshi Bhattacharya, Jadavpur University. Anindita Saha, Techno Main, Salt Lake, please be ready. Pritam Kumar Soor, Government College of Engineering and Textile Technology. Thank you, sir. I now request Professor Bashok Chaudhary to present the presenting author certificate to Reshmi Maulik, Meghnad Shaha Institute of Technology. I request Reshma Roy Chaudhary to please be ready. Reshma Roy Chaudhary. CAC Department, Heritage Institute of Technology. Thank you, sir. We thank all the reviewers for their constructive and timely feedback, which helped to maintain the quality and standard of the conference. I now request Professor Proshenjit Gupta to please present the certificate to the reviewers. Professor Rituparna Sinha. Professor Joydeep Das. Professor Rituparna Sinha is from IT Department, Heritage Institute of Technology. Professor Joydeep Das, BCA, the Heritage Academy. Professor Devlina Chaudhary, CAC Data Science, Heritage Institute of Technology. Professor Shobhoshatri Chatterjee, EC Department, Heritage Institute of Technology. Professor Anindo Sen. Professor Anil Bagh, AEI Department, Heritage Institute of Technology. Professor Anil Bagh. Professor Shumon Ghosh, MCA Department, Heritage Institute of Technology. Professor Orpita Talukdar. Professor Orpita Talukdar, CSC, Data Science, Heritage Institute of Technology. And I also request Professor Nilina Vera of CSC Data Science Department to please be ready. Thank you, sir. Next, the student volunteers. So what can we say about them? Yes, thank you. Whenever we think of the student volunteers, it reminds us of Kobiguru's line, Amra Notun Jobaner Dut. They have been truly very spirited, full of enthusiasm, and they have been responsible for doing all the groundwork. Without them, this conference would not have been possible. So big round of applause for all the student volunteers. I request Professor Dinobandhu Bhandari, Program Chair, Track B, AI and Machine Learning of ICAA 2026 to please come up on stage to distribute the certificates to the students. Akash Kundu, CAC 4th year. Anjishnu Mukherjee, CAC 3rd year. Ankit Roy Chaudhary, MCSE 1st year. Intake 1st year, Intake CAC. Arunna Basu, CAC 3rd year. Orijit Chatterjee, CAC 4th year. Orijit Chatterjee, CAC 4th year. Aryan Ghosh, CAC 3rd year. Thank you, Professor Bhandari. Please take a seat. I now request Professor Shubhashish Majumdar, General Chair, ICAA 2026, to please come up on stage to give the certificates to the students and encourage them. Ashmit Paul, CAC 3rd year. Atif Ali Sardar, CAC 3rd year. Mubik Bhanja, CAC 4th year. So Mubik is probably busy today doing some groundwork because nothing can be done without them, right? Devojit Kanungo, next, CAC 4th year. Priyanshu Priyadarshi, CAC 2nd year. Rishabh Sen, intake first year. Deepika Goswami, PhD fourth year. Samar Singh, CSE second year. Nishita Goswami, CSE fourth year. Next, Samar Singh, CSE second year. Shohini Ghosh, intake first year. Srijit Roy, CSE third year. Shubham Mandal, CSE third year. Mia Shubham, CSE third year. And finally, Shatutru Roy, CSE fourth year. Thank you. Thank you so much, sir. And thanks to all the students once again handling all the departments of the conference. Atithi Deva Bhava. It is the tradition of India to consider its guest as Deva, that is the Lord. It signifies hospitality and brotherhood. We hope we have been able to live up to that expectation. To share a few words and their feedback, I will now request first John Iacono, University of Brussels, Belgium, to share a few words. Next, I will request Uros Sibes, University of Ljubljana, Slovenia, to share their experience and feedback. Thank you. A big round of applause for them.
Everyone, I'd like to thank you very much for the kind invitation to come here and the incredible hospitality, especially the organizers and all of the volunteers and students, and those that came pick me up at the airport and everything. I very much appreciated everything that you've done. I've also very much appreciated the scientific content of this conference. Both the invited talks, which I found very interesting, along with the many contributed talks of very high quality. So I'd like to thank you very much, and I'll hand it over.
Okay, yeah. First of all, I don't know if I'm qualified to give a very good talk, because there's so many things that I have to congratulate you on. So thank you for the organization, for the hospitality. I consider myself a veteran of this conference, even though this is the second time I'm here. The first time I was here 12 years ago, and the first edition was very good. I was also asked to give you some feedback at the end, and I said that I wish this conference will continue. And unfortunately, the next year it was not continuing. So I was very happy to hear when Subhashish contacted me if I can come. Last year I couldn't come, and this year I'm very happy that I'm here. So thank you for all the organization and all the very nice presentations, both from invited speakers, and of course the other fellow authors. I was here in a couple of roles, but I think I enjoyed the most sitting there and listening to some very interesting topics. And thanks for the lovely cultural program yesterday. You showed that you have a lot of talent, and this talent propagates also in other areas, as we can see in this conference. So thanks again, and I really hope I can be here next time as well.
I now request Professor Dinobandhu Bhandari to please come up on stage, and I request Professor Subhashish Majumdar to please felicitate Professor Bhandari, because he has been one of the pioneering members and responsible for getting the conference up on Sprinter in time. Professor Bhandari is the program chair of Track B, AI and Machine Learning. I request Shri Pradeep Agarwal ji to please deliver the certificate for session chair to Professor Paramartha Datta. Please come up on stage. I also request Professor Sujoy Saha to please come up on stage to get the certificate for session chair, and I request Shri Pradeep Agarwal to give the certificate to Professor Sujoy Saha. Thank you so much. Now, we are moving towards the end of ICAA 2026. I request Professor Bhandari to deliver the vote of thanks.
Good afternoon. Respected dignitaries on and off the dais, professors, students, ladies and gentlemen. As we come to the conclusion of the International Conference on Applied Algorithms, ICAA 2026, it is my distinct honor, privilege to deliver the vote of thanks on behalf of the entire ICAA team. These 3 days of intellectually simulating discussions, insightful presentations, and enriching interactions have been made possible through the contributions of a large number of individuals and institutions. With deep gratitude, I acknowledge them all. First and foremost, we extend our sincere thanks to our advisors, Sri H.K. Chaudhary, Sri P.R. Agarwala, Sri P.K. Agarwal, Professor Basuk Chaudhary, Professor Shobhi Bhattacharya, and Professor Sujit K. Bodua. Thanks to Professor Bimal Roy and our ED sir for their gracious presence in the dais today. Our heartfelt appreciation goes to our steering committee chairs, Professor Bhargav B. Bhattacharya and Professor Sandeep Sen, for their leadership and constant support. A special note of gratitude to our General Chair, Professor Subhashish Majumdar, our program chairs, the timely publication of the conference proceedings in LNCS Springer a day before the inauguration stands as a testament to their diligence and commitment. An outstanding achievement and a proud moment for all of us. My heartfelt gratitude towards the authors, program committee members, and the reviewers. And I know the reviewers were disturbed during the Puja vacations. Thanks to you. I express my sincere gratitude and I acknowledge the efforts of the organizing committee and the organizing chair, Professor Digant Sengupta. Our sincere thanks to Sri Manoj Saraogi, the finance chair of the conference. We extend our gratitude to our publicity chairs, Professor Shubhasati Banerjee, Professor Niranjanaji Basu, and our registration chairs, Professor Paulami Das and Professor Uttusa Das, for their unwavering efforts in ensuring excellent visibility and seamless participation. Our sincere thanks to our chief guests, Professor Shantanu Choudhury, and our guest of honor, Sri Joyabruta Ghosh, and our guest Professor D.K. Banuet, and for gracing the event and enriching the inauguration with their words and presence. I express our profound gratitude to all our distinguished invited speakers, Professor Partho Bhowmik, Professor Gautam Das, Professor Somarjit Chakraborty, Professor Swagotam Das, Professor John Iacono, Professor Shubhamay Moitra, Professor Kurt Melhorn, and Professor Durga Madhav Mishra for sharing their expertise and inspiring us with their thoughtful, provoking perspectives. A special appreciation goes to all our session chairs. I'm not naming them all, for maintaining the academic rigor and ensuring meaningful discussion during the sessions. I would like to take this opportunity to express our profound appreciation for the exceptional cultural event. It was a beautiful display of talent and tradition. It resonated everyone present in the audience. Our words may not be capable of fully communicating the sense of gratitude to the performers and the cultural committee. The evening was a perfect blend of learning and leisure, and we thank you for the enriching experience. Thanks to all the participants who made the cultural event a memorable one. Your contribution have made this conference truly special. Our heartfelt thanks to a Joint Registrar, Arvind Srivastava, and Lieutenant Colonel Amitabh Ghosh, Dostida, for their overseeing logistics with precision. We are deeply grateful to the system team led by Mr. Devashish Karmakar for enabling seamless online and offline sessions, and to the Department of Media Science, the Heritage Academic led by Professor Dr. Madhupa Bokshi. Their efforts ensured that the conference reached audiences across the globe. Our warm appreciation also goes to Pradeep, managing audiovisual and lighting arrangements in the SV auditorium, and to Vicky and Prabhat for ensuring hospitality and refreshments were available throughout the event. A special word of gratitude to our student volunteers whose enthusiasm, discipline, and proactive support kept the conference running smoothly. They have truly been backbone of this entire event. Finally, to our participants, delegates, attendees, and well-wishers, thank you for your engagement, your questions, and your presence. Your involvement has made ICAA 2026 an intellectually vibrant and truly memorable conference. If anyone has been inadvertently omitted, I sincerely apologize. Every contribution, big or small, has helped make this conference a resounding success. On behalf of the complete ICAA team, I thank each one of you and wish you safe travel, continued collaboration, and lasting academic connections. We look forward to seeing you again at future editions of ICAA. Thank you. I request for General Chair declare it closed. Please.
Okay, dignitaries on the dais and off the dais, my dear faculties, my dear students, ladies and gentlemen. What can I say about a conference which starts with a Padmasri and ends with a Padmasri? Okay, I think the government will be happy about it because the name comes out. Okay, the name of the national flower comes out. Okay, now, so you know, 3 days has been quite a lot for me because I had to obey dress rules, okay, which I don't normally. And normally I'm generally with a t-shirt and jeans like John. It's an old graduate habit, but I had to take the order that I have to dress in a certain way. And more importantly, I would say this is the first time I prepared a speech for the opening ceremony. I have never prepared a speech and then read it out. So there are some sats and madams in my department who said that you always do a lot of humor during the address. You should not do that. So this time I followed it. I know somebody is there who understands, who told me that last time. So I made it sure. But today, when the all job is done, and in Bengali what we say, motamuti digantor meer biye hoye gelo. Now I can tell you a small joke, okay? So this is a joke from our young times, younger days. So there's a ship going, okay? At that time, there was not so much of flights, so a ship going, and suddenly people saw that while going from Calcutta to Andaman and Nicobar, one child fell in the sea, okay? And everybody was shouting, he should be saved, he should be saved. I'm telling it in English, because so that John and Gurus can understand. So he should be saved, and somebody please jump. And then suddenly somebody really saw that somebody jumped from the ship, and he went and swam across and then saved that child. He was saved, say he was Mr. Save. Okay. Now, typically what happens after such things, there is a felicitation ceremony, and then everybody was telling very good things about his jumping from the ship and saving the child. And then at the end, Mr. Sen was asked to say something about it. And what he said, first of all, I want to know who pushed me out of the ship. Okay. So all of you understand, I'm feeling like Mr. Sen, okay? Thank you for being here. Thank you for being here. I want to clap for all of you. I now declare this conference closed. We look forward for the next edition. I will try to defer it as much as possible. Let me see. Okay. And now, please do not leave the hall. We'll have a group photo to capture this event in our mind. Okay. So please wait for the group.